Morning, everyone. Now, I presume the big green button means go ahead. That sounds good. Good plan. Excellent. Thank you. It'll come as no surprise to you that there's been plenty of rain around this year, and it set the season up in a number of ways. These two maps up there are just from the Bureau of Met deciles. So the decile ranking, I'm sure you're all familiar with that one. It's just a way of ranking things from highest to lowest and seeing where the current year sits in terms of the historical context. The map on the left just shows the January to March rain. A lot of tropical rain, cyclone or two, active trough, that sort of stuff. So pretty much by the end of March there had been a lot of soil moisture in most of the western districts, not so much around the Esperance area. But then, crucially, it was also followed by a growing season. That's what the map on the right is, which is April to October. In general, it was up and down a bit. There was a lot of rain, as you were all aware, in the great southern east of Albany from a couple of weird events, a bit strange things. Anyway, a lot of rain for there, a lot of waterlogging, as you're all aware of. The northern grain belt actually got pinched with water towards the end of the season. August was pretty dry, so it wasn't all rain the whole time. It was highly variable. But in any event, you certainly had a lot of summer rain, soil moisture, early sowing opportunities. That comes as no surprise. And then follow-up rain. But there was more to it than that story. And what I've tried to do here was to try and pull out typical patterns of rainfall. And the top bar graph looks at the years since 1999, where I've just grouped them according to high production, average production, or low production years. So the years that were high production are the green bars in the top one. You worked out the ones at the brown are the average, and the ones in the green, the ones at the blue with the below average years. Those three sets look at the seasonal rain over that blue area in the map there. And so it's December, January, February, March, April, May, June, July, August, and September, October, November. So essentially that breaks it up in terms of the summer, the autumn, the winter, and the spring. But then crucially, the spring rain was about normal. So that pulls the fat out of the fire to a certain extent. And then typically the high production years, as you might expect, doesn't matter so much what the summer rain's done, but crucially the early part of the season, March, April, May, is above average. So that gets pretty obviously things going. Winter rain has still been a bit below average, but it doesn't matter so much because most of the crops don't use it that much anyway at that time of year. But then, importantly, spring is above average. And the bottom plot was how those anomalies went for this year. So the left-hand one is December, January, February. So it was across that area above average, a good start. And a lot of that was influenced by the rain northeast of Albany. So it was wet to begin with, and then above average winter, which is a bit unusual nowadays, and above average spring. So we very much followed that pattern of what would have led up to a high production year. The other story is one of temperatures, and these are slightly complicated sets of graphs. The top left one is the maximum temperatures in September, and rather than just showing deviations from average, these are the rankings, the temperature deciles. And so the brownie bits, as you show on this map there, it showed that the maximum temperatures in that top left one were warmer than average, notably. They're in the top 20% of years. The next graph along just shows when you look at the events above 30 degrees or so, and this was looking at just the first half of September. It was really only the northern grain belt and bits of the northern bits of the Esperance area where they got one or two events, so there weren't a lot. And there were some follow-up ones in the northern grain belt in the second half of September. But as far as the days above, say, 32, 33, there weren't very many of those. And so the field reports coming back was that even though at that time of year a lot of the crops didn't have a lot of soil moisture, they were able to fill grain pretty well because they didn't get the heat shock. And so that was the report coming back. Minimum temperatures, so that's the bottom left. Again, September was about normal for minimum temperatures, with a little bit cooler than average in the eastern grain belt, which was shown very much by that bottom middle plot, which was the minimum temperatures in the first part of September. And it was very much some severe events, but it was, rather than it being in a lot of the central grain belt, it was very much in the northeast areas. And so there were a lot of events there, some individual properties quite severely affected by that. And then the bottom right plot was just that where the number of events or the days below 2 degrees were then counted for that period. And so some of it was in areas that normally do get it, as expected, But it was a bit different this year in that more of the events were clustered out in the northeastern grain belt. So the impacts were spread around in some slightly different areas. The top two pictures at the right, that's again the deciles of the daytime maximum temperatures and then minimum temperatures for October. So in general, October was pretty mild. And so that was part of the story of having a relatively soft finish. So temperatures had a role to play. The northern grain belt was exposed a bit because they were running out of soil moisture later in the season, but they had a pretty mild September, so that certainly helped a lot. So we had both the rainfall pattern, which should in principle give you lots of soil moisture, and it did, potentially high production year, but also the temperatures came into play. So whilst there were some hot days, there weren't that many, and frost was certainly there, and it clipped it severely in some parts, but it wasn't as widespread as in past years, so that was good. The other major thing, I guess, in terms of these major climate drivers that was going on this year was this thing called this Indian Ocean Dipole. So we love acronyms, IOD. The schematic there is from the Bureau of Met's website, and that really just shows a map between Australia, Indonesia, tropical Indian Ocean into Africa. And in it, the pattern that it had this year, the so-called IOD-negative, the waters around Sumatra and north of Australia are warmer than average, and that tends to be cooler than average off East Africa. The grey circulation there shows the east-west circulation of the tropical winds, and otherwise known as the Walker circulation. And what tends to happen that in the tropics, the convection follows the sea surface temperatures. So you tend to get enhanced convection around the Indonesian area and suppressed convection around Africa. What that means for Australia is that you just got events which are generating moisture. They're generating, so that what the clouds are doing effectively is just transporting that up into the upper atmosphere, and that gets picked up by high latitude weather systems. So the top right picture is the canonical, the typical pattern in 11 composite years when this sort of pattern happens. And again, this is rainfall deciles, so a lot of Eastern Australia tends to have a wetter period, and that's a June to September period. And so tends to be wetter. It doesn't make that much of an impact on Western Australia. There's some dry years, there's some wetter years, there's some average years. So it doesn't push it around as much as it does for Eastern Australia. The good thing, however, it's not associated with dry conditions. The opposite phase of that IOD thing called IOD positive, definitely suppresses our seasonal rainfall. So that was good, but that was one of the reasons why Eastern Australia's had such a wet start. And that's before the La Nina events kicked off. And the plot on the bottom there was just how the rain turned out from June onwards. So again, it matched that pattern reasonably well. That is, it certainly got wetter for Eastern Australia and the southeast. And there's a number of things going on this year. La Nina's kicked off in the southern hemisphere. There's the southern annular mode that's kicked off. That's going to bring rain for the southeast, so it's going to keep on going for them. And so, just in summary of the growing season rainfall, as you're all aware, was very much set up to give potentially good production. It's consistent with a high production year. The temperatures came to play, and it was generally mild, and so that certainly helped crops to finish. It had been certainly frost, but they were displaced more to the northeast, so the events seemed to be highly variable. On some properties were indeed affected badly, but others not so much. But it was, in the context of a high production year, there was concern that you'd end up with something like 2016, which fortunately didn't happen, which was also IOD negative year, by the way. The event that's going has just about finished as the summer monsoon kicks off. That'll knock that on the head, so that's just about gone. A La Nina event has kicked off in the Pacific Ocean, so that's going to affect the east coast and keep them. Doesn't really do much for our summer rain, which is why the summer rain outlooks for our part of the world are mostly neutral. They don't really care. Probably means a bit of summer thunderstorms, as you might expect, but not particularly wet. That's the key thing coming out of that. But temperatures are likely to be up a lot for the west coast, but cooler for the Esperance area. And I guess it'll come as no surprise, consequence of that is the bushfire risk will probably be enhanced. There'll be a lot of biomass. It'll dry off. It'll be hot for the west coast. So you don't need much of a crystal ball to work out that bushfire risk will probably be enhanced this year. So I'll leave it at that point, Sally, if you want any questions.
Okay, we've got some time for a few questions. Did you before we go on to Dion, is there any questions? Or you can put your questions into Slido as well. So, Alice, because I'm sorry, what happens? We keep going?
Keep going. Okie dokie, no worries. So we can catch up later anytime.
Here we go. Oh, Sally, what's your name? My name's Sally Peltzer. Sorry. How did the early rainfall predictions match up with reality?
It depends what timescale you're looking at. The seasonal stuff, the models were actually at the start of the year, so let's say the summer rain, January to March stuff, the bulk of the models thought that period for WA was likely to be wetter. So in the early part of the season, that pretty much came off. When you then rolled into winter, more of the models, because there's about a dozen models that you can look at, and so you can do a multi-model comparison. So more of them had what was called as a neutral outlook, meaning they had no preference towards wetter or drier. So it means they were all sitting on the fence, unlike Eastern Australia. So it's difficult to score them in that sense. There were some models that did persistently do better. There's a couple of them. The ECMWF and the Japanese Met Agency consistently got seasons right. And so rolled into spring, they tended again they reduced the chances of dry conditions, so they're mostly neutral or slightly wetter. So they didn't do too badly. The trouble is, if you do a multi-model thing, you chuck it all in the big bin and stir it up, they tend to cancel each other out. So we're tracking individual model performances. The Bureau of Met's model had some right, got some wrong, but there are a couple of international models that seem to have been doing consistently better. And as their tech evolves, over time they are getting better, but they're not magical. They're certainly better at the multi-week and the week time scale, and they were getting those things pretty right, largely because that's related to the lifetime of weather systems. So at the shorter term stuff, they're kicking off pretty well. At the 3-monthly lead time stuff, there's still a bit of work to do, but that's largely because they're trying to detect these big picture, these climate drivers like IOD or other sorts of things. It means if nothing's going on in those things, then the models are going to say nothing's going on. So they're not magical in that sense. They are detecting what the sort of major climate systems are up to. Cyclonic activity this year probably enhanced a bit because of the La Nina. And what the La Nina does, it just cranks up the tropics and gives more opportunities for these systems to form. You're probably going to get warmer sea surface temperatures around the Indonesian area. You're probably going to get a stronger Lupine current. There's a risk of coral bleaching events in the Ningaloo area. A stronger Lupine current coming down the coast, so the ocean temperature is probably going to be a bit warmer. So that's the stuff coming out of La Nina. IOD, I think it does, what does the IOD effect have on spring temperature? I have to dig that out a bit. I think the IOD positive drives up temperatures, and the IOD negative probably suppresses them a bit. Driven a lot by 2016, which was a particularly cold spring. So there's that one. Yes, sorry, I'm just going through all the questions, sorry.
No, we'll go on. If we've got time at the end, we'll answer a few more of these.
Yes, but certainly rainfall and temperatures are linked, that's true.
All right, so I always feel a bit awkward doing this, considering most agronomists would know pretty well what's happened through the season, but I think just for the conversation today, it's important to sort of recap, I guess, where we were thinking along the way during the season. Obviously in March, had this a few times out Mucka and Merredin Way this year, and it was good to get that sort of confidence before the season. There's growers out at Bonnie Rock and that had 300 mils of rain from harvest to seeding, so the signs were pretty good from the start about what was going to be a potential setup for the whole season. Pre-seeding, having that ready to go, and this is actually seeding during March, which is a bit of a push much earlier than normal at Ben Coven. But, with that abundant rainfall, it was especially good seeing just how many growers had very good summer weed control this year. Compared to what we'd put up with 20 years ago, it's a huge improvement in keeping our yield potentials up. Some growers have been back over the same paddocks 5 times over the summer just to try and maintain that potential. So it's one of those things that, again, next summer, I mean, I don't know if we're talking 3 or 4 times the price of Roundup, we might be looking a little bit differently at some things, but I think it was good to see people maintain that driver yield potential. And obviously with that rain going into March and then Cyclone Seroja, we really had the biggest green light we've probably ever had for planting as much canola as what people could manage. And it's always interesting seeing in March or April people thinking about canola as what can I physically harvest as the decision tool with how much canola you plant, which is just, again, it's a very, I don't know how many times in a lifetime we'll get seasons like this. It was good to see that going forward, at least in low rainfall. Those intermittent marginal conditions that we had in patches between the thunderstorms and cyclones and everything else also meant growers were sometimes looking at what other options they could squeeze in between. So, for example, pulling the Illabo winter wheat into March before they were comfortable to plant their canola, or then looking at, you know, deep planting of lupines into April conditions and things like that to try and work around those conditions. Again, it showed a lot of system sort of approaches and a lot of changes to people really on the front foot trying to make the most of that potential. And obviously in the eastern wheat belt, I have a lot of early sown spring wheats being in that second half of April as well, chasing that potential. So the winter wheats, you know, really is a lot of growers had a crack at Illabo this year, considering, you know, really it's been missing as a farming system for quite a long period of time. It wasn't without its challenges. So some growers, for example, that did have pasture paddocks within the nearest 20 k's that actually were the source of locusts and that. You know, some of them had to start getting planes in April and things like that, which again is not something they're used to having to deal with. But having that much moisture underneath and having the confidence to pull that ahead was one of those things that you know, again, it was fantastic to see people able to turn on a new system for their farm at least, and get these opportunities captured. The other thing was, it was pretty, I think it was probably the most envious year to drive to work past everyone driving tractors, considering it was, you know, just the best seeding conditions really. The amount of time in the low rainfall, the guys weren't putting up with dust and could actually see the bar most of the time through seeding. It certainly made me a bit jealous. And also meant we were getting the germination of our weeds aligning with a lot of our activity of preems, and so generally speaking, a lot of growers also had pretty good weed control from really most of the grass weed control option in preem. Obviously, early May rain actually got very wet on some of the heavier soils and some of the areas around granite and things like that. So that effectively did slow down a lot of the growers that were steaming ahead, which I think was probably quite fortuitous, given the way some of the season panned out. And you know, there were some growers that had breakdowns, various things, and then they had the rain and they were starting to get very concerned. But the way a lot of it went, it still panned out pretty damn well. With getting that crop through. So later on though, dealing with the wet winter conditions, the trafficability across a lot of the state started to become an issue, even the low rainfall, where, you know, being able to get on those paddocks and spray or apply nitrogen started being a real concern. Obviously with the whole state having such a big potential year, you know, the drivers of getting nitrogen and the ability to turn on such a massive change in the supply chain was obviously a massive task. Price of N went up, and people often then starting to wonder when I can get that nitrogen delivered, you know, and at that price, you know, how risky is it to go out there and chase that potential? But generally speaking, the supply chain did a massive increase in the amount of nitrogen that was available to growers, and the use of N was very high. Generally across the board. So, you know, growers did really, I think, an agronomist did a fantastic job of trying to really capture that water limited potential and matching those inputs to that. Obviously in the eastern wheat belt though, as Ian mentioned, you know, there was some significant setbacks in some areas. You know, frost on the 3rd of September did quite a bit of damage around Merredin and east and some of the areas north of there and Bruce Rock. So there's a lot of those patches, you know, you were looking at the best yield potential wheat getting the most damaged. And luckily though, there wasn't a lot of frost events in truth this year that I thought were damaging. Really, this was the main one for the state. So as Ian said, you know, really we probably got off quite well. But particularly those areas in the east, it was a bit disappointing seeing some of the potential slip away from them, considering how well those crops were set up. Just to give you an example, this is some data from our time of sowing trials in Merredin. And so if we see in 2020, we can see particularly when you start sowing those spring wheat, the longer maturity spring wheats early, you really start chasing a much higher yield potential. Now this year, the frost occurring when it did really just capped off all the highest potential wheat, to be honest. So one of the big factors about that is you know, the location, the soil type, all these other factors become a big part of it. But certainly this is the time of sowing trial that we've got at Merredin. This is the data we've got in so far this season. But you can just see there's a massive hole in where the highest peak yields were. So over the last 5 years, setting things up to chase, whoop, and I'll go back. Yep, beautiful. Chasing this potential has been, you know, just such a significant winner over the last 5 years, and now this year, you know, this obviously hit that there. So what you would do in future to manage that, I mean, I think for a lot of growers having the same season, they'd probably still do the same thing just because you're chasing that potential. And also after that, this particular site, this is what some of the crops started looking like towards the end of August and into September. You know, you'd gone from being effectively waterlogged to suddenly too dry in a matter of weeks, and a lot of the crops really struggled. And what we also saw is after that frost, a lot of the crops on these tighter soils really struggled to recover and to compensate. You know, some of the later tillers weren't doing too well, while when you get onto the kind of soils, a lot of those were actually able to develop normally and do quite well where they were better hydrated. So that had a big impact on what the final yields were, considering the recovery from that frost event. So, you know, when those frosts occur, I mean, the reality is economically damaging frost can occur at any time. You know, and while phenology is typically your best tool, it's not perfect, and chasing that yield potential is still a big part of profitable farming. But, you know, the factors that mattered most, I guess, for a lot of growers, it's still going to be the geographical location of the farm in terms of having a bit of a spread of risk in terms of the layout of your farm. The distance across those programs are still probably the biggest factor. But then obviously topography, soil type, crop types, sowing times, you know, all those factors came into it. I still think there's a huge difficulty in predicting yield loss from frost, and that's the reality of it. You know, we had a lot of people being very busy in September trying to work out what the potential loss was going to be, and I'm not sure we've got a particularly strong confidence interval on those predictions, just quietly. So, you know, we really don't know, particularly when we've got north of $300 a tonne wheat price. No one wants to cut hay, do they? So it's and that's part of the challenge I see in WA, is that there is, you know, often such a big gap in the system between being able to salvage crops. It's really not a particularly competitive thing for most growers. So, you know, that's something that maybe, you know, got so many people in the room, it's probably worth discussing at some point about ways to try and close that gap in competitiveness, given that other parts of the world, be it sub 2 tonne Texas or whatever, you know, a lot of other parts of the world, they'll have much better crop salvaging options that are much more cost competitive against the grain. So that's still, I think, a constraint. But again, you know, like, it's not just about wheat either. The other crop types and things like canola did very well this year. And a lot of novel issues I thought show up this year as well. You know, Russian wheat aphid spread throughout the state. Roughly, how many people here saw Russian wheat aphid this year? Can I just get a show of hands? Yeah. Did anyone see any economically damaging levels? No one, yeah. So that was the same, I thought. And so it was one of those things that we just didn't know what was going to happen. The symptoms really stick out like a sore thumb. But it's, I think it was a relief to not see them personally. They didn't look any worse than the other aphids, and the other aphids are still probably driving your choice of whether you sprayed or not. For low rainfall, we don't tend to get a lot of mites and things on wet crops. You know, we don't tend to have as wet a crops. There was other factors that, you know, during the winter suddenly could get away from us and have to catch up. Physiological yellowing was pretty severe in those prone genotypes. There was a lot of discussions of that through the year. There's a lot of panic towards the end there about mice in WA. I understand there's still a fair bit of bait on farms if anyone wants to buy any, is my understanding. But, you know, it's one of those things, we just don't know what the levels are when we need to start dealing with that, considering the things that were in the east, and also some of the reports that we had from the north of the state. You know, just I remember speaking to a mate from New South Wales to see what sort of levels he was looking at where they had serious mice problems, and the quote that sort of stuck in my mind was, he goes, "Oh no, it's heaps better now, we can't hear them anymore." And I didn't want to tell my wife his quote in case she ever thought that was going to happen at Mucka, but it's one of those things that we, you know, 20 years ago I remember trying to unblock the sieves relatively frequently and swath canola to try and get the mice out of the sieves, you know. They're always there, what levels, you know, so some of those things were some of the uncertainties we had to manage during the season. This is very much not discussed or really seen just because it tended to be the very last stuff that no one was really looking at, but there was even some cases of stripe rust and other things appearing at the very end of the season with that October rainfall. So there's other things out there that were creating those sort of uncertainties, if you like. You know, at the end of the day, we had a wet season and we've got very good prices for most of the commodities. So generally speaking, we're pretty happy and most growers are very happy. Canola, obviously, for most growers, talking decile 10 yields and decile 10 prices. It's pretty hard to compete with that. It's done extremely well. And in terms of frost, you know, it really probably performed the best out of all the crops in terms of maintaining that yield potential. Lupines got an increase in planting this year, which was good. And there was a lot of high biomass and didn't look particularly reproductive sort of crops, but you know, the yields have varied, but most have been pretty good in a lot of the Kwinana East, and most growers are pretty happy with that. Chickpeas, on the other hand, all the growers I've spoken to with their chickpea crops were rather disappointed. Just the combination, I think, of some of that frost and then running out of water was probably a bit of a challenge for some of those crops. The barley generally yielded well, but had more test weight issues with frosted grain in some of those earlier crops in particular. Oats, I didn't really see anywhere near the planting of oats in this year as what we saw in, say, 2016 in the Eastern Wheat Belt. Most oat growers are still pretty happy with it, but there's also that issue with the lack of oat and hay markets this year that's affected some of that crop as well. And with the wheat, of course, you know, in the areas that got hit hard with frost, it was hitting generally the highest yield potential wheat. But we're still looking at most growers still achieving, you know, well above average yields across the farm and you know, record prices, so people are very happy. And here's some of the high potential chickpea crops that some growers were disappointed with. And obviously there's prices. The other factor is that we're now contending with is some of the increased spread between some of the protein seeds and things like that. And you know, that's part of the old conversation that happens during wet seasons, and we often talk when we start getting lots of low protein wheat, it's always the conversation of, you know, how do we fix that? The challenge is this data from the 1980s, and you can see we've got years in the 1980s, even when we had lower yielding varieties, we had more pastures, we had far more conservative cropping rotations. We still have years where we had below 10% as a state average. So the reality is when the big seasons come, you know, it's very hard for us to honestly expect to lift the protein up across the state. It's just a reality. If the yield potential just keeps going up and up and up, it's very hard to start fertilising beyond that yield plateau and trying to drag up the protein. But it's still very profitable, isn't it? All right, so I'll leave it there.